For those of you who don't know me, my name is Janice Cobb. I graduated here last year, 2014, with the AIAA, and minor in multidisciplinary design. So I'm the current YP Deputy Director for Region 3, which is the US of today, which is really cool, and also the Young Professionals Chair for the Michigan section. And today, basically, for all you students and professional members, we're just going to meet each other and learn about what the Michigan section does and a little bit about who we are. So I'm going to introduce Thomas Borowski. He is our current section chair for the Michigan section of the AIAA. And section chair since 2012. He got his bachelor's degree in aerospace from the University of Michigan in 1985. His master's degree from the University of Florida in mechanical engineering in 1995. Worked at Rockwell International on the B or the B bomber flight simulation and controls. Then moved on to Pratt & Whitney military engines in performance testing methods. And now he works at Williams International on the advanced design team and is an engineering specialist.
Thank you. Hi, hello, how are you? Good. Beautiful spring day here. I'm glad you guys turned out. We hope to provide you some value here. Something a little bit different than your class. I'm not going to try to teach you anything about aerospace in particular. I just wanted to talk about aerospace in general. What happens when you get out of this wonderful little cocoon and get out into the world? Real aerospace. So we're going to talk. It's a young professionals meeting. It's supposed to. We're going to try and have some back and forth conversation. We actually have, besides myself, a couple other professionals here. Jeff Benko from CD Adapco, it's a CFD software group. Jeff Urbon, also from Williams International, and also our treasurer for the Michigan section. And Larry Powell, consultant and most recently from GM, and he'll tell a little bit about his background. Blank down your name. Okay. So all four of us, all five of us, all six of us, who are out in the professional, no longer student. We'll try to tell you a little bit about some different aspects of being an aerospace engineer. If you have some questions, what do you do in your first day of the job, things like that. We'll talk about that. This is meant to be kind of a let's talk about some of the issues that come up. Clicker. So I'd like to, like I mentioned, talk about what it's like to be an aerospace engineer. Are there any opportunities in Michigan? You have to go to California to be an aerospace engineer. That's what I thought. That's what I did when I got out of school. I drove off to Los Angeles. There's opportunities in Michigan. There's opportunities in the Midwest area that we'll talk about a little bit. I'm not going to give an exhaustive list of all the companies, but I am going to talk about a few particular ones here in the state of Michigan, and there's some real opportunities. And then finally, once you get out, how can the AIAA help? What is there to do? What's the Michigan section do? What does the national organization do? Why should you keep or stay in the organization? I selected this one because once you get out, what's it like to be an aerospace engineer? When you first get out as an aerospace engineer, I hope you feel just like this. And then you get that feeling of like, all right. Okay, I went through all the tough CFD stuff. I know now your Stokes. I can do some stress and strain analysis, and now it's time to get out and apply myself to the world. And that is exactly the attitude and the talents that companies are looking for. They want you to come in. They don't expect you to know, the exact details of how to build and launch that rocket on your first day on the job. That's not the expectation. But they do. Oh, Logan says they do. What companies are looking for is new approaches, new attitudes, the new things you've learned in school, and your ability to learn new things and to come at problems with a fresh perspective. But at the same time, being willing to work on some established projects. So who here among the students is planning to work on satellites. We were thinking about satellites. All right, a couple. You think or spaceships, actually making spaceships. Right? When I got out of school, I kind of felt like it was not a real robust, the shuttle was kind of like already developed. Apollo was way in the past. The space station was kind of like, oh, are they ever going to do the space station? It was 30 years ago, and it's taken them the 30 years to get it up there and move it around in the sky now and do great stuff. And it might feel like, okay, the space station, it's kind of done, but it's like NASA's talking about Space Station 2. They haven't named it yet, they haven't had a concept for it yet, but things will continue in space. Things will also continue in aeronautics and aeronautics in particular. And I've got a picture here of a pilot kind of focusing on, here's the whole human interface, making things fly. Is she a rare bird? Is she about to be one of the last pilots out there? Is everyone going to be a UAV pilot? Hard to say. And would that be a good thing? Hard to say. We don't want to completely lose the skill of flying, but a lot of mundane flying will obviously be going towards some kind of unmanned vehicles. Like small, more dangerous jobs at first, but I think you guys work on courses where you get to build UAVs, and you're going to be bringing that in. And if you've read anything in the AIAA daily briefing, they talk about it every day. There's the growing pains of legal issues, and capabilities not quite there, and how do we integrate it in with the NAS, the National Air Control System, whatever NAS stands for. But to fly safely fly with the same level of safety as human piloted aircraft now, and interact in a very logical, safe, predictable way. But my point is that the UAV industry is going to continue to grow, and its value is going to be billions per year. It's going to be huge. So if you're young entrepreneurs, it might be a good time to take a real big risk and start with start your own company, or get in with a small company, take a risk on that. So, now things are kind of moving along where a lot of people can do their own small companies and exciting things happen. There's opportunities in good old-fashioned aerodynamic design, innovative aerodynamic designs, the power of computers and the power of CFD is becoming such that things are just accelerating so quickly that things that people, there's a lot of ideas that people tried, from before the Wright brothers, through the Wright brothers in the 20s and 30s, all kinds of crazy contraptions, and some things didn't work, some things were, big flops. But a lot of those things had a kernel, a little nugget of a good idea in there that couldn't be done with materials, back 100 years ago, couldn't be done with applications 50 years ago, couldn't be done even with control systems 10 years ago. But maybe, maybe some of these things are like, okay, let's take some risk and let's try some new things on the aerodynamic side, as well as the rocket side. Rocket side here, the big dramatic part here, propulsion is what makes vehicles go. That's an important part of any aerospace project, and it's a long lead item a lot of times on new projects. And you're going to build your new aircraft around the propulsion that's available, or the propulsion that you're going to help foster and develop, like the Joint Strike Fighter. The Joint Strike Fighter required whole new development of a concept and a propulsion system, and the propulsion system was started a good 5 years before, most of the work got really going in earnest in the aircraft. So that's kind of my view of, there's a lot of possibilities out there in space, air, and I hope you feel like a kid in a candy store. You're ready to get out there and get going. I'm going to talk a little bit about something that I know a little bit better, and it's with engineering, literally an engine. This is one of our it's an engine for a smaller aircraft, an FJ-33. We do the inlet and the inlet duct, the nozzle, and the entire engine as well, and the some of the control system elements. So Williams does quite a bit, and we integrated it into one package here. This is going on a Cirrus. Anything interesting about that nozzle for a business jet? Is it a straight nozzle? A vector nozzle for a business jet. It's an innovation we came up with kind of go along with the installation of the back spine of the aircraft. And our expansion geniuses kind of thought about it and looked at how the engine was performing and actually, came up with a method of vectoring like that, so that when you're taking off, the pressure ratio of the nozzle at takeoff, the thrust, the flow is in a low enough pressure that it can suck up to that top surface and kind of vectors up 7 degrees, kind of giving you a nose up 7 degrees. When you get out to cruise flight, the Mach number kind of changes a bit, the conditions up the back, pressure drops, the vector comes back down and attaches to the bottom wall. You get this automatic vectoring between takeoff and cruise, and both of them are in the ideal position. It's like a little talk about what Williams does. It's just a picture of one of the things that we work on, that Jeff and myself get to work on. Are there opportunities in Michigan? I talked a lot about Williams because that's where I work, that's what I'm familiar with. There's a couple other companies that are of pretty significant size, GE Aviation in Grand Rapids. This is something good to know, but something you should kind of pay attention to is that aerospace companies evolve and eat each other and grow by mergers and acquisitions and that. So GE acquired this from Smiths Industries, which is a British company. Smiths Industries acquired it from Lear, and Lear had been out there as this Lear Corporation doing control systems for a number of years. And now as part of GE, we've had help from some of the GE folks, and I have a slide to talk about them in detail. Another company you might not think about in Michigan here is Roush. Roush, and I've got a slide about them, but they have some dealings in aerospace. BAE Systems in Sterling Heights. I'm not exactly sure what they do. I kind of just did a web search of some of the big names popped out. General Dynamics Land Systems Division, that's over in Livonia, Warren, the one in Warren, okay. So aerospace, part of that is kind of like dealing with their systems and environmental control systems kind of ideas. There's actually a pretty good sized manufacturing company, Eamer Corporation up in Lansing. Larry's going to talk about the automotive side. I put down some of the bigger companies here. They all have big offices, and I'm sure there's more. Eaton kind of works with control systems. And one of the things the AIAA has done in the past or they talked about, is taking a tour of the Delta Airlines depot right at the airport. It's actually quite an extensive operation there in terms of doing aircraft maintenance. And then also, I'm not sure how extensive their engineering is, but they have to have some role that they play in making purchasing decisions and things like that. There's a variety of aerospace companies in Michigan to consider. I'm going to talk about Williams International just a little bit more, and then we'll call on some of the other members here that can talk about some of their professional activities. So this is the front page for Williams International. World leader in small gas turbine engines. I gave you a photo of one of the engines there. We're located in Wall Lake, and I'll talk about a tour that's available a little bit later. We have one tour per year that's available. So talk a little bit about that later. A number of your classmates from prior years have come to work at Williams, either as interns or as full-time. So there are good opportunities. Things are expanding there right now, which is nice. Roush is, like I said, based in Livonia, best known for automotive performance and racing. We did have an activity there, this talk with talking about race car aerodynamics, so we got to see the place a little bit and find out about. I didn't really even know about their aerospace, what they've got at hand in aerospace, but it includes
manufacturing, rapid prototyping, kind of advanced composite stuff, fabrication kind of things. But I know they also are they've got a project that's going to be up on the space station, a Stirling cycle engine for energy production as a part of a solar concentrator Stirling cycle project that's going on. So, Roush is another one that you might not come to mind right away, but, one that you get working. Before we talk about GE, Jeff and I have a little story there. Perhaps we'll invite Larry to come up or talk as he sees fit about his career and things that he's done in aerospace. This is Larry Howell.
Thank you. Well, it's a pleasure to be here, and just to give you a little of my background, I have an undergraduate and PhD from the University of Illinois in Champaign. I was fortunate as a graduate student to get some really interesting summer jobs. In 1966, I worked in Seattle for Boeing. Stress analysis for what they call the variable camber crew. It's actually a medium-inch flap from the 747. But I'm proud to say it still works. I worked for General Dynamics Fort Worth on the F-111, again structural analysis. I actually worked for Northrop before they were Northrop Grumman on the 747. Just to give you an idea how old I am. When I was at Boeing, they were working on developing their first finite element code. Of course, they didn't have computer capability to do very much with it. When I graduated, I became a senior dynamics engineer for General Dynamics in San Diego, working on space shuttle structural dynamics. And I spent several years there. These were NASA land contracts. I had a friend who recruited me back to General Motors, and so I went to the GM R&D Center in 1972. My first management job at GM was head of the engineering mechanics department at the R&D Center. We were responsible for structures, crashworthiness, occupant protection, noise and vibration, and aerodynamics. Does that sound like aerospace engineering to you? Similar stuff. I retired as the executive director at GM in 2001. Actually, what I wanted to talk about, though, was some of the softer side of the engineering profession. Develop good communication skills, writing and speaking. It's critically important for your professional career, particularly if you want to participate in societies like AIAA. It's also important if you ever want to get into a leadership position. Teamwork is very important, collaboration. And I don't mean just working as a team, but sharing your knowledge with other engineers. It's a tremendous benefit for you personally for that and for the organization. In a lot of companies, product groups develop what they call networks of centers of expertise. People who specialize in certain specialties like structures or control systems or whatever. And they collaborate in such a way that they help the whole group become stronger and stronger in those technical areas. It's a real asset for the company. Sharpen your pencil. Again, that tells you how old I am. But by that I mean be rigorous and objective in your work. Be very careful in the work that you do. It's important. Double check suspicious looking results. Ask others to check your work, especially in critical areas of engineering like safety, because lives don't depend on it. A little bit about R&D. R&D is very different from production engineering in the sense that in R&D, you're frequently taking a lot of risk with the projects that you do. And that means they're not all going to succeed. But you have to look at that not as a failure, but as a learning. It's just as important to know what doesn't work as it is to know what doesn't work. Be willing to tell it straight to management. Sometimes there's a pressure to make things work. You want to be able to say really what the data tells you. And I guess one of the greatest compliments I got from one of my former managers when I retired was he didn't always like what he had to say, but we knew what to tell him. So that's very important. That's all I got.
All right, thank you, Larry. That was unexpected surprise. I'm going to tell you more than I know about GE Aviation Systems. How about that? They are located in Grand Rapids. Jeff and myself, actually 7 years ago, they did have a tour. I hinted around for them to do another tour. We'll see if we get any kind of response. They at least participated by providing the sheet here describing themselves, as well as working on the election committee. The elections for the Michigan section office are coming up again, and I tapped them again to run that committee. And hopefully, we'll just quickly get through that and get the word out about who's running for different offices. But they work on avionic systems, aviation computing systems, navigation and guidance systems, integrated vehicle health data management systems, black boxes and mission systems. Actually, quite a bit about this, mostly for my wife, because that's the exact type of system that she works on, controlling jet engines. So she works on the biggest full authority digital engine controls, which control the engines as a single black box. You might have two processors for each engine, and it's what it controls the engine and communicates with the aircraft. So they break down the systems controlling the aircraft into a number of smaller discrete units that can develop independently, test independently, and then integrate all together. And the integration of all these parts is the service that he is providing for Boeing for the 777 and the 787 over in Grand Rapids. It's quite a project, and I think I looked at their website, and I think they had just won some new additional work from Boeing, and possibly some from Northrop on another project as well. But I think they seem like a pretty good organization. The Grand Rapids area was very interesting, and they do a lot with the flight control. So you really got to know and understand the aircraft side of it to work on these type of systems as well as the electronics part. But seems like an interesting area to go. And then they mentioned electrical power systems, digital solutions. I'm not quite sure if that is correct, and structures. So there's some additional aircraft work on the electrical side and the structure side, and putting things together that they do over in Grand Rapids. We'll talk about the AIAA in a little bit, but maybe we can open this up a little bit and talk a little bit more with we got the students over here, kind of, and the professionals over here. But what are you curious about when you go into aerospace? What are the kind of things that you wanted to ask somebody who didn't know who to ask? Go ahead.
I have a question. It's not as deep as that. I'm not actually curious. How many registered members are there in the Michigan State section?
Luckily, I know that there's about 530 registered members. Quite a few of them are students, and then we've got educator associates. So elementary and high school teachers can sign up. And it doesn't cost them anything, so they sign up pretty readily, and then they can play when they get emails from me. But in general, we kind of worked all that out. So we've got the email server system, and there's about 50 or so educator associates, several hundred student members, and then the remainder are kind of scattered at the corporations. For the most part, the corporations I mentioned are the big ones. But there's also a lot of some smaller people that are just consultants on their own, or they have 1 or 2 employees. So there are some smaller companies that I did retail here in Michigan. They do exist. And a lot of the professors as well. And the professors want to start their business occasion as well.
Okay, so I think a good question is, how do you transfer knowledge from the senior people to the new young, fresh employees who just joined the company? How you do that works in the industry?
That's a good question. That's actually a topic that was kind of a big topic of concern at the recent Aerosciences meeting, and the chairman, what is his name, was talking about that. I was watching his speech, and he spent a good deal of time about that. A big part of the reason is the age distribution here. We've got, this is not exactly the answer, you see that? So here you are, you get out of college, you've got zero experience, but the distribution of folks, we've got a little bit of a recession there, but we've got a group of folks like this, people with kind of out here 10 years experience are not as prolific, and then 20 years experience, and then 30 years experience, and kind of ramps up. So our industry right now, the aerospace industry has a great big wave of folks that kind of come in, they've been there a long time, and that's exactly the knowledge that corporate leaders are worried about transferring. Probably the best way that I seem to work on that is have people work together on projects. A younger engineer kind of be an apprentice almost to a senior engineer, then the senior engineer guide them through projects. And there's, there'll be some effort required on your part to seek out that senior person. They might not be directly assigned to you. You might hear just like, well, if you talk to so-and-so, he can tell you a little bit more about structures. And if you go and talk to him, you might, the first time you might be, oh, this is a long story, and he goes on about his kids, and he can tell you something. And so there's going to be some effort required on your part to really seek out and pull that information out of them. On the other hand, they are willing and interested in transferring that knowledge, because everyone in the aerospace industry is fairly aware of this. They'll walk in, you'll see a gray hair, and they'll say, okay, where's the young people? Where's the continuum of people? And it's not quite there. Aerospace does go off of that. Anyone else want to comment on that?
Yeah, this doesn't really solve the problem completely, but at one time I know that Boeing had what they call design reviews, multi-day design reviews when they're working on their project, whether it was wing structure or whatever. And the existing team in-house would invite in a bunch of old retirees like me who've made a lot of mistakes in the past, and have them set through that review and point out sometimes something that the other team didn't see. So that was sort of a discrete transfer of knowledge. I'm sure hopefully it's not.
Any other thoughts? Any other curiosities? Things you're curious about?
I was just going to comment that at Williams, most of the star young engineers are put on a rotation. That's about 6 months in a specific discipline, so that you have an idea or a notion of what you like to do eventually. But you spend at least four rotations every 6 months, and you get an opportunity to see what other people do, and you also get mentored through that process by the senior members in that particular discipline. So in that case, that's a perfect opportunity to pick someone's brain and transfer them.
That particular program at Williams, I like that a lot. I didn't participate in something like that. I just kind of was put into my first assignment and kept at it for a number of years. And when you're selecting your first job, you're not exactly sure what the heck the job really entails and if you'll really like it. So you have to make a big decision with kind of limited information. So sometimes you'll pick the perfect job for yourself and you'll fit right in. Sometimes you'll have a situation where you can move around a little bit. You got to be honest with your manager. If you are in a situation where you're like, I'm trying to do this structures work, and geez, I'm not really it's not clicking with me yet. I want to go and work on something else. So besides the analytical side, I do cycle analysis. So it's thermodynamics all day long, and I love it. You know, you think, okay, some people are weird. People can get into a certain discipline, and then they'll want to try something else out. Like, so the project area and the test area are more akin to engineers have, you know, it's like that the designer comes up with something, and you've got to go out and get it built in the shop, go to suppliers and get the different parts, the ball bearings, the tubes, the whatever, and you'll get to work with a senior test engineer and get something to test. They've got a procedure. They're not going to turn you loose and do it all on your own, but it's a great opportunity for more of a hands-on experience, or more experiences working with customers. And you start out at an entry level of that, and they'll say, like, okay, now you need to go, customer has said this, you need to go do some analysis, you need to do some research, and then put together a presentation about here's something that would meet the customer's need, and what's the real physics behind what they're asking for. It's not a simple, straightforward, oh, I can look at the catalog of what we've got available. A lot of design work that goes into even dealing with customers.
I would say it's also going to vary on what size company you're entering into. Like larger companies, most international, you know, those have been around for a long time and will have kind of that chart. Other companies like the Adapco has always been a growing company. The CFD continues to get more and more prevalent. And so you're seeing much more of a, you know, you have a lot of younger people and not so many of the older. And so it's, you know, it's also a more dynamic environment, so that the new people that are entering are contributing, you know, from the start as well. Various, you know, and that, as I was saying, you know, you might take that into consideration when you're looking for your first employer. You know, do you want somebody big, somebody small, and especially with aerospace now, you know, you're really getting a lot more into the smaller companies are an option. You know.
Yeah, I think smaller companies have a better chance to succeed than they did in the past, when it would take hundreds of people to get anything substantial done. And now it's a small group can design something, print it, and test it, and there you go. No, on the computer. Give you a widget. Other questions? Go ahead.
So I've heard, like, when you start out in industry, you know, you're going in some particular direction, but if you're not careful, like, you can end up getting pigeonholed into some very specific thing, and then you end up not having a lot of flexibility in your career afterwards, because everyone knows that this is the stuff you worked on, and that's like the kinds of roles that we put you into. Is there a way to make sure that, like, you can stay flexible throughout your career versus getting directed onto a path and then not really being able to break away from it?
My advice in that regard would be sometimes you can try and broaden yourself out, especially the companies that encouraging you to broaden yourself out. Sometimes you can do the opposite and kind of lean in. And what I mean by that is that, let's say that they want you to kind of be the expert in a particular area. Let's say they want you to be an expert in a CAD system. It might not be bad to kind of look into it and find out about what kind of groups there are. Are there some CAD standards? Is there a CAD, like an SIE committee that meets and sets up standards and applies those standards? Kind of lead in even further in that regard as a way to talk and to broaden yourself and to give yourself an opportunity and a good excuse to talk to other managers and break out. Like, you're so much of an expert that you can then go to other departments. That's one thought that comes to mind. All right. Any other advice?
I guess for me, I got hired in at Ford as a climate control engineer, so that's like very specific part of a vehicle, and I felt like I was gonna get roped into doing that and like have to do that forever, but it's not the case. Like, when you're a young engineer, they give you so many opportunities to learn. So I've gotten to go to like I've learned SIA and CFP and Fluent all the time. Like the 9 months that I've been at Ford, they sent me to these classes where I went to a week-long class for CFP here in Ann Arbor. It was like $3,000 class that just sent me to. It's like, oh, you want to learn CFP? Okay, go ahead. And like they just sent me. So if you're interested in learning those things and trying to experience new kinds of technology or different software or just different areas, they'll totally let you do it. You just have to speak up and be like, oh yeah, I'm interested. Can I go do that? And most often they're gonna be like, yeah, let's send them so that they can do more things and you're not just stuck in like these engineers like all I know how to do is Excel. Like, you want to be able to have lots of skills so you can go and do all those different things and you won't be stuck in one area.
Yeah, the older guys, we really want you to show us what is Python, and where you talk about Python. And so, no, yeah, you blow my mind with all that stuff, or whatever. Yeah. And so the fresh new approach and the knowledge of the latest computer science and how it applies to engineering is, I think, is definitely your foot in the door to really expand. And Janice said it right in the head. 4 questions. Everyone's going to ask 1 question. Okay.
Thinking about
He's
it.
thinking about it.
Sure, can go first.
What is each person's experience been with aerospace in Michigan as a state compared to the other places that you've worked in the past? How's it compared for just the quality of living? Because as a senior, looking towards graduation, one of the filters they try and have you apply when you're searching for a job is, oh, what region would you like to be in? And there's California, and there's Texas, you can be in Colorado, there's a million locations. I've lived in New Jersey, I've lived in Michigan, and I've driven through the other states. But it's it's a big decision moving out. I'm going to pick up and move somewhere. What have you guys learned from working for different companies, working in different locations? What types of positive and negative aspects of you guys come across?
Kevin, you always worked here?
When I first got out of undergrad, I moved to upstate New York and worked for General Electric.
Oh, that's right.
And spent a few years there. What I found was a couple things you find in Michigan. One is the fresh water, the abundance of fresh water that you don't find in Michigan. That's one thing. And then the other thing is every time there was a break or a holiday or something like that, I find myself driving back to Michigan. And so for me, it was being born and raised in Michigan, you sort of gravitate towards that. And of course, there's excellent opportunities in Michigan, like Thomas is outlining a few of them here. So I think if your climate and what you consider standard of living, cost of living, those sorts of things, it's an easy decision.
And Larry, you went out west.
Yeah, I went to San Diego for my first permanent job.
How did you leave?
Yeah, that's what the mailman said when I first got my transfer from San Diego. It's part of what he just said. I mean, if you grew up in the Midwest, it feels like home. And California's great. The weather's nice. I mean, it's warm pretty much all my friends came out to golf with me in January and all of that. But when we moved back, my wife said, I'm really glad.
Yeah. We moved out to Los Angeles also. We tried that for 3 years. It was right in Los Angeles, right at the I was like on the airport property or right adjacent to it. So that's if you've been to Los Angeles, that's a busy area. And it just wasn't working out financially. So then we moved to Florida. And Florida was pretty nice. We were on the Atlantic coast, in Florida, where Pratt & Whitney is now. It's not Pratt & Whitney kind of shut that plant down, and now they've reopened it quite extensively. So it was a different lifestyle. It was a warmer lifestyle. And then when we moved back to Michigan, we did kind of come back after 20 years and look at it with fresh eyes and say, like, what's the cost of living? What kind of house can I get? And we did settle on that. So you gotta make those decisions, and you gotta
if you're willing to take a chance in California, give it a try. Or Arizona or Colorado, there are some a lot of awesome choices.
I think the downside of LA and San Diego and San Francisco today is the traffic. I got off the plane last time I was in LA in the middle of the day. Stop. They do have water problems.
Yeah.
Serious. I have relatives out there who have rational showers. I'm not trying to put down California, but parts of California are very nice too.
So as an individual decision, you gotta be willing to take, how much you can tolerate, how much risk you can tolerate. And, obviously, if you all move around, or not all of us, but you get to move around too, you're not stuck in one place. So, I wouldn't say, yeah, you all must stay in Michigan, that's not how it goes. Everyone's gonna try different things and have a strong desire to go to one place, SpaceX, I go to SpaceX. You might go to SpaceX and you might love it and flourish, or you might be like, oh, not exactly what I thought. That Elon guy's a little weird or something. He's quite a maverick.
But Seattle's numbers are terrific. My friends
Yeah.
But we're in Seattle now, so it's all good. SpaceX has a Seattle office now as well, so they're out.
There you go. It's getting close to 7. I know you guys all have to study and all that, so I'm going to cover this quickly, and then we'll have a chance to talk after as well. The Michigan section offers networking opportunities. This is a great one. Thanks, Janice, for putting this one on, but we have other ones as well. We have distinguished lecture events, a lot of them here in Ann Arbor, but we've also done them at Lawrence Tech. We're trying really hard to get one at East Lansing this year, and we've had them in out at Western as well. We want to continue to do that. Something you might not, I know you're probably not aware of, is the Congressional Visit Day. It's once a year. We have like 2 representatives or one or 2 representatives go to Washington to present the AIAA's 10 talking points to the state senators and congressmen. It's a one-day kind of structured meeting. So you have like a day, you go out a day ahead of time, do preparations, and kind of learn the 10 talking points, and then you represent the Michigan section. And you're wondering, why am I telling you this? Well, there's also, I would really like students to participate in this as well. So it's a short little trip, perfect for a junior or senior to latch on to. So contact me about that if you're interested. Rocket Labs, I think we've got a sign-up list. Logan's already talked to a lot of folks about going to some K-12 schools for a one-day outreach. We did it as 2 days last year, and all the professionals were like, okay, let's just one day. We'll get quick dry and glue and watch it. And the students, we gotta give them a background about rockets. You can, impress them with rocket science, and then we want to build a rocket. There's a tour upcoming here for Williams, limit to 30 total folks. So sign up quick when you see the email tomorrow. I think April 10th is the date. It's like the week after, the Friday after Easter. 9 a.m. probably to 3 p.m. Lunch will be provided. U.S. persons only. Introduction to Williams, a factory tour, repair station hands-on tour. Does anyone remember that? You can take apart an engine. It's got hands-on. Test cell tour. So these 2 days, we don't. Williams does not offer factory tours. It's a very private corporation, and students are the only ones once a year that actually get a chance to do this tour. And then the repair station hands-on part, where you actually get to take apart a jet engine. I never got to do that until I went on the tour. And I've only been in aerospace for a little while, so. And that's it. I got a few more, some more information about the commission. It's available. There's a couple, the website for Williams and the website. And then I got a quote here from team about how they're doing right now. So a few openings, 47 jobs out there right now. I don't know if they're all engineering, but there's, and
And I know we have 18 jobs. I know they're not all engineering jobs, but we have 18 positions open at the moment, so apply now.
Okay. So we have like, you guys are welcome to stay and when you want. There's pizza and cookies and stuff like that. Mingle and network with the awesome people that are in this room and learn a lot from these people. Which is basically the goal of this whole meeting, is just to meet the members in the Michigan section, what we're doing, and we want to pass on the knowledge. Not really my knowledge, because I don't really have that much yet, but all of their knowledge. So, they will all talk. Okay.
All right.
Thank you, Thomas, for.
One question that I wanted everyone to hear. It's not as much a question as a suggestion, but we were talking about, passing on the knowledge from the senior level to the entry level. And what would be the possibilities of, putting together maybe a mentorship program between students in the state of Michigan and the section members from the state section? Put students in a one-on-one connection with the community.
I'll let others comment on that. My own feeling is it has some good possibilities, but it also has it bumps up against the possibility that you've got full-time jobs.
Yeah.
So it's tough to for people with full-time jobs and families. It might be tough for them to actually carve off time and make it a worthwhile endeavor. I think once you get out of the industry, that'll be a little bit. You have to get some of these ways to do your management, and that's really what happens.
There's a lot of opportunity as it is. I mean, at Williams, we have to hire juniors and seniors for internships. There's a lot of things.
Yeah.
We're not trying to
Kill the idea.
kill the idea. Like when you meet people, definitely take their business cards or ask them questions while you meet them. It's just hard for us to set up hey, you have to go meet this student at this time for this amount of hours, to do that kind of thing. But definitely branch out, talk to people. That's probably the best way. And when they respond and you get a good conversation going, that's probably the best way to start that mentoring.
When you have them, at least, a number of years ago now, I think they had kind of an entry connection. I know there was somebody like that connected with for at least a brief period of time. I don't know if that's one way, but that's also
Jeff, how about you comment on you've been on a couple of AIAA committees, like the propulsion committee. That really, explain what that is and how that works.
Well, being at Williams International, we have a representative that supports the AIAA. And at one time, it was a single technical committee, it was a gas turbine engine technical committee. AIAA has probably 35 to maybe 40 technical committees now. So if you're into acoustic structures or if you're into rock engines or whatever, there's a technical committee that they're always looking for people to help out, to be part of the committee, to take a leadership role in the committee. At the time I was being at Williams, it was sort of like a rotation where every couple of years they'd have another guy be on the technical committee as a Williams international representative. And at the time I was on the gas turbine engine technical committee, they branched into 3. So they had still gas turbines, and then they had sort of like a substructures for gas turbines, and then high-speed technical committees. So we spawned into 3 technical committees. I was part of that spawning procedure, which was quite fun, and you get an opportunity to meet and network with plenty of very high-skilled and very approachable people being on the technical committee. I would do it again in a heartbeat if I had the opportunity to. It was a lot of fun.
As students, you guys can find all these technical committees online. They're all listed on the AIAA website. And as students, they actually want you to participate. We've been told this a couple times at the SciTech conference, and they're actually looking for students to kind of just listen in or just sit in if their teleconferences or at their community meetings if you're at the conference. I think Joey actually sat in on a bunch of them. past January. And they're very open to students participating. So if you find something that you like, definitely talk to the leader of the committee and just be like, hey, like I'm interested in your committee, like send me some information or whatever, and they'll be glad to look you up. And like so you can start getting involved that way, which is a great kind of segue from student to professional member. And as a young professional, it looks really good if you're on time committee. And you're just like, I'm a member of this like really intense technical committee, so it's like,
Another opportunity for technical committees is they have student design competitions too. And I was at the conference in Cleveland last summer, and they had a propulsion design contest. These people walked away with $1,400 each, the winners. There was a group of like 4 people. I was like, wow.
We should have designed that. They're kind of describing these committees, and I would imagine it sounds a little mysterious. What would a committee do? Why would there be a committee? What the committee is made up of, I'll give you an example of members from General Electric, Pratt & Whitney, and Rolls-Royce. How are they going to get anything done? Because they're bitter rivals, and they're going head to head against each other and trying to beat each other. But at the same time, they also need to deal with the same customers, Boeing, Lockheed, and they've got to provide them. They need to cooperate so that they can come up with a more consistent product, and that's because Boeing and Lockheed is insisting on that kind of behavior from corporations. And then when folks actually get together, they don't. The guys from Pratt and the guys from GE don't share secrets about cooling flow technologies for the turbines. That's ITAR, that's the keys to the kingdom. They're not going to share that information. But at the same time, the physics is physics, and they have a pretty good idea of what the other guy is doing, and it's not that much different, and there's only so many materials out there. So there's competition and cooperation at the same time on these committees, which is a very interesting dynamic. And it'll let you know, you'll get to see that aerospace is kind of a small community. You get into the rocket side, there's only a few people that make rocket engines, few companies, and they kind of know what the other one does, and they compete for the same contract, so they know, they're both trying to please the same customers. So it's a small community, and then people actually do move from company to company, and they get to know people. So that's another neat thing about aerospace. Is you'll find that you join this community. You might not know all the players at once, but pay attention, and pretty soon you'll start to see people a little bit more often, or maybe, oh yeah, I worked with him 10 years ago now he's back. So things have a way of going around. That's a lot of fun too. And the committees, I think that answers kind of your question of what if you get too much into one area. It's like, well, that's kind of what I was referring to as a way to broaden yourself out, to ask for other assignments, other training. So. We'll gather around, we'll eat pizza, and then I guess we can chit chat and tell us some about your projects, what the projects you're working on as well. I'd love to hear it. Thanks. Famous picture of it. This inside that, or?
Yep.
Yeah.
Okay.
Al Romig and John Tracy.
Yeah.
Oh, and now we'll mix.
Yeah, Al Romig and John Tracy on this, right? Oh,
I can say
Friends here, my recruiter friend.
Oh,
You guys know.
I